بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. معاكم مستر أسامة العوضي. النهاردة إن شاء الله معانا فاينل ريفيجن على الجبرا تالتة إعدادي إن شاء الله الترم الأول. بإذن الله مع بعض هناخد المين بوينتس كده اللي في الجبرا في تالتة إعدادي إن شاء الله في الترم الأول. ونبدأ مع بعض طبعا يا شباب في أول ليسون درسناه مع بعض اللي هو الكارتيزيان برودكت. فلو احنا عندنا مثلا set x equal 1 and 2 set y equal 5 7 8 we want to find x times y أو x Cartesian product y. طبعا Cartesian product means a set of all ordered pairs whose first projection of each of them belongs to x and the second projection belongs to y. So x times y equals set of 1 5 1 7 1 8 and 2 5 2 7 2 8, and we can represent it by an arrow diagram and the Cartesian diagram. Arrow diagram, as we can see, we draw set x 1 2, we draw set y 5 7 8. There is an arrow from 1 to 5 and from 1 to 7, from 1 to 8, as 2 from 2 to 5, from 2 to 7, from 2 to 8, and we can represent it by Cartesian diagram. We draw x on horizontal line and y in vertical line. X equal 1 2 5 7 8. So 1 5 we put point, 1 7 point, 1 8 point, and so on, 2 5 2 7 2 8. But if we wanted to find y times x means set of all ordered pairs whose first projection belongs to y and second projection belongs to x. So y times x equal, we start with y, element of y, 5 1 5 2 and 7 1 7 2 8 1 8 2, and we can represent it by an arrow diagram and the Cartesian diagram as shown. If the set of all ordered pairs whose first projection and the second projection belongs to x, this means x times x. X times x, Cartesian product for x times x means the set of all ordered pairs whose first projection and the second projection belongs to x. So x times x equal 1 1 1 2 2 1 2 2, and we can represent it by an arrow diagram and by Cartesian diagram. So x from x to itself, x1 2, x1 2, 1 2 1, and 1 2, 2 1 2 2. And we can represent it by another arrow diagram as shown and the Cartesian diagram as shown in the figure. Some important remarks: x times y not equal y times x, or where x not equal y. N of x times y equal n of y times x equal n of x times n of y, where n is the number of elements. N of x times x equal n of x square equal n of x all power 2. X times 5 equal 5 times x equal 5. And we study the relations and its representing. What about the relation? Relation from set x to set y is a connecting, joining some or all the elements of x with some or all elements of y. And if R is a relation from set x to set y, then R is set of ordered pairs where the first projection of each belongs to x and the second projection belongs to y. R subset of x times y. The relation can be represented by an arrow diagram and by Cartesian diagram. If R is a relation from x to x, then R is a relation on x and R subset of x times x. Let's take an example. If x equals set of 1, 2, 3, y equal set of 1, 2, 3, 6, and R is a relation from x to y, where A or P means A is a factor of P. For each A belongs to x, P belongs to y, then write R and represent it by an arrow diagram. From the relation A is factor of B, we can write the relation R equal set of ordered pair 1 and 1, 1, 2, 1, 3, 1, 6, 2, 2, 2, 6, 3, 3, 3, 6. As we can see, 1 is factor of 1, 1 is factor of 2, 1 is factor of 3, 1 is factor of 6, and 2 is factor of 2. 2 is a factor of 6, and 3 is a factor of 3, and 3 is a factor of 6. And we can represent it by an arrow diagram and the Cartesian diagram as shown. Set x, set y, from 1 to 1, from 1 to 2, from 1 to 3, from 1 to 6, and also from 2 to 1, وهكذا. What about the function? A relation from x to y is said to be a function if each element of the set x appears only once as the first projection in one of the ordered pair of the relation. Each element of set x has one and only one arrow going out of it to one element of y. Each vertical line has one and only one point lying on it, the point which representing the relation in the Cartesian diagram which represent the relation. If x is a function from set x to set y, is written as f from x to y, then x is called the domain of the function f, and y is called the codomain of the function f. The set of images of the elements of the set x by the function f is called the range of the function f, which is a subset of the codomain y. For example, if x equal 1, 2, 3, y equal 1, 4, 9, then the following diagram shows some of the relations from x to y, and we note which of the following relation represent function from x to y and which doesn't represent. The first relation, going out only one arrow from each element of the elements of x, then the relation is a function from x to y, and the domain is 1, 2, 3, and the range is 1 and 9. Here, there is going out two arrows from the element 1 in x, so the relation is not a function. There are not arrow going out from the element 2, so the relation is not a function. Another examples or another diagrams. Here, each vertical line has only one point lying on it, so the relation is function, and the domain is x, 1, 2, 3, and the range is 1, 4, 9. Here, there are 2 points lying on the vertical line at the elements 1, here and here, so the relation is not a function. There is not a point lying on the vertical line at the element 3, so the relation is not a function, and so on. What about polynomial function? The polynomial function is a function whose rule is a term of an algebraic expression in condition that the following should be identified. Each of the domain and the codomain of the function is the set of real numbers. So the domain and the codomain must be set of real number. The power or the index of the variable x in any of its term is a natural number with nothing that the degree of the function is the highest power of the variable. Degree of the function means the highest power on the variable x, and the power must be natural number. We can find that, we can notice that the function f such that if x equal 3 is a polynomial of 0 degree. F of x equal to x plus 1 is a polynomial function of first degree. F of x equal x power 3 minus 5x power 2 plus 1 is a polynomial of third degree. The function f such that f of x equal 1 over x power 2 plus x power 2 is not a polynomial because 1 over x power 2 equal x power negative 2, and the negative 2 is not a natural number, and the index is not natural number. Graphical representation of the polynomial function. We take the constant function such that f of x equal to, so we represent it by a straight line parallel to x-axis and passing through two lines in y. F of x equals 0, the straight line is coincident with x-axis and passes through the point 0, 0, and it has no degree. Here, f of x equal negative 3, straight line is below x-axis and passes through the point 0 and negative 3, and it's of 0 degree also. The linear function. Linear function, f from R to R, where f of x equal ax plus b, a belong to R, difference 0, b belong to R, is called a linear function of the first degree. and it's represented by a straight line intersecting y-axis at point 0b and x-axis at negative b over a and 0, such that f of x equal 2x minus 3. To draw this relation or this linear function, we make a table x and f of x. We put x equals 0, 1, 2, any values we need, and we find f of x opposite to all the values. We put x equals 0, so 2 times 0 equals 0 minus 3 equal negative 3. Put 0, x equal 1, f of x negative 1. Put x equal 2, so f of x equal 1. And we can represent it by a straight line as shown in the figure. Another example, f of x equal 3 minus 2x. We can put x equal 0, 1, 2, and we can find f of x for each value, and we represent it, and we notice that it's a straight line. What about quadratic function? The function f of x equal a x power 2 plus bx plus c, such that a, b, and c belongs to R and a not equal 0, is called a quadratic function, and it's a polynomial function of second degree. And it's represented by a curve whose vertex is negative b over 2a and f of negative b over 2a, such that f of x equal x power 2 minus 3x plus 2, and x belongs to 0 and 3. So we take the lower limit of this interval 0, 1, 2, up to the upper limit is 3. And we find f of x, we put x equal 0, so f of x equal 2, put x equal 1, f of x equal 0, and so on. And we can represent it by a curve as shown in the figure. We can find that the vertex of the curve is 3 over 2 and negative 1 over 4, negative v over 2a and f of negative v over 2a. The vertex is 3 over 2, and we find f of 3 over 2 equal negative 1 over 4. The minimum value of the function, negative 1 over 4, and the equation line of symmetry x equal 3 over 2. Another example of x equal to x minus x power 2 and x belongs to the interval negative 1 and 3. So we take negative 1, 0, 1, 2, 3, and we find f of x negative 3, 0, 1, 0, 3, and we can represent it graphically as shown in the figure. And the vertex of the curve equal 1 and 1. The maximum value here is 1, and the equation of line of symmetry x equal 1. Let's move to the ratio and its properties, ratio and proportion. We know that the ratio between the two real numbers a and b is written as a to b or a over b. A is called the antecedent of the ratio, b is called the consequent, and a, b are called the two terms of the ratio. The value of the ratio doesn't change if each of its terms is multiplied or divided by the same non-zero real numbers. If the ratio between two numbers is a to b, then the first number equal am and second number equal bm, such that m not equal 0. Two numbers, their sum is 28, and the ratio between them is 3 to 4. What are the two numbers? Let the two numbers be 3m and 4m, so 3m plus 4m equal 28, so 7m equal 28, m equal 4. So the two numbers are 3 times 4 and 4 times 4, 12 and 16. What about the proportion? Proportion is the equality of two or more ratios. If A over B equals C over D, then A, B, C, and D are called proportional quantities. A, B, C, and D are proportional quantities, then A over B equals C over D. The properties of proportion. Property number one, A over B equals C over D, then A times D equal B times C. This means the product of extremes equal the product of means. Example, find the force proportional of the quantities 3, 4, and 27. Let the force proportion be x, y, or z in symbol. So the quantities 3, 4, 27, and x are proportional. So we we make a proportion 3 over 4 equal 27 over x. So x equal 4 times 27 over 3 equal 36. Then the force proportional equal 36. Property number 2, if A times D equal B times C, we can make a proportion as the following: A over B equals C over D. Let's take an example. If x plus 3y over 2x minus y equal 4 over 3, then find the ratio x to y. X plus 3y over 2x minus y equal 4 over 3. So product of extreme equal product of means. So 3 times x plus 3y equal 4 times 2x minus y. By simplifying, 3x plus 9y equal 8x minus 4y. So x to y equal 13 to 5. Property number 3, if a over b equals c over d, then a over c equal b over d. The antecedent of first ratio over the antecedent of second ratio equal consequent of first ratio over consequent of the second ratio. Property number 4, if A over B equals C over D, then A equals Cm, B equals Dm, where M is constant and not equal 0. Let's take an example. If A to B equals 3 to 5, then find the ratio 20A minus 7B to 15A plus B. A over B equals 3 over 5, then A equals 3M, B equals 5M. By substitution, 20A minus 7B over 15A plus B equals 60M minus 35M over 45M plus 5M. By simplifying, equal half. If A, B, C, and D are proportional quantities, we assume that A over B equals C over D equal M, then A equal BM and C equal DM. There is a lot of example. Let's take an example. If A, B, C, and D are proportional quantities, prove that 2A plus 3C over 7A minus 5C equal 2B plus 3D over 7B minus 5D. A, B, C, D are proportional, so A over B equal C over D equal M. This means that A equal BM and C equal DM. The left-hand side, 2bm plus 3dm over 7bm minus 5dm. By simplifying, equal 2b plus 3d over 7b minus 5d equal right hand side. Property number 5. A over B equal C over D equal E over F. If A over B equal C over D equal E over F, and so on, M1, M2, M3 are non-zero real numbers, then M1A plus M2C plus M3E over M1B plus M2D plus M3F plus وهكذا is one of the given ratio. Let's take the continued proportion. The quantities A, B, and C are said to be continued proportion if A over B equal B over C. A is called first proportion, C is called the third proportion, and B is called the middle proportion. A over B equal B over C. This means that P power 2 equal AC and B equal positive or negative root AC. The middle proportion between two quantities equal positive or negative root the product of two quantities. The two quantities A and C should be either positive together or negative together. If A over B equal B over C equal C over D equal M, then C equal dm and B equal dm power 2 and A equal dm power 3. Examples such that A, B, C, and D are continuous proportion prove this the following. A, B, C, D are in continuous proportion. This means that A over B equal B over C equal C over D equal M. Then C equal dm, B equal dm power 2, A equal dm power 3. Then 2A plus 3C over 2B plus 3D, and so on by substitution. This means that equal M. What about the right hand side? A minus C over B minus D by substitution and simplifying equal M. So we deduce that the right hand side equal the left hand side. ده يا جماعة نهاية الفيديو بتاعنا النهاردة. إن شاء الله نشوفكم في فيديو جديد، والسلام عليكم ورحمة الله وبركاته.